Right everyone, I've got to the point now where I'm pretty much ready to get it all prepped, ready for assembly. So obviously the boiler tube here, these are the end plates, it needs drilling still. This is the phosphor bronze, it's going to be the phosphor bronze stay that's going to go through it with the nuts which are made in here. So these are the pieces, there's the piece of copper that you've seen me make. Ready to be soldered to the back. That's obviously the piece of brass that goes onto it for the fittings. Some more of the fittings. There's a nut for this stay, the phosphor bronze stay. And that's a 1/4 inch by 40 tooth per inch thread tapped out to. Another piece for the boiler. Another nut. And obviously these here, you can pick them up. They're the fittings. Now, like I said, I was away on holiday, went to Wales with the family for a bit, and had a few days away, and I was reading this book. I don't know if you can see that. It's called Model a Locomotive Boiler Making by Alec F. Farmer. And it's a really good book. It's basically all the processes of how you go about making a boiler, copper boiler, for a miniature engine. Obviously this is a train, not a traction engine like what I'm making. A bit more in depth, but it's really, really good, really interesting. Loads of points and tips and techniques that I picked up in it. Some really cool tools that he's made as well, custom made tooling, like press brake. There's some drawings in here that he's done. One he's made himself with photos. You know, this is really useful. This here is like a way of grinding the drill bits for drilling plate steel like copper. So instead of creating a big burr as you drill it, it comes out, removes it like a piece of swarf, like there. Rather than gripping the material. So that's pretty interesting stuff. Obviously it's probably a bit outdated now, but you know, these have been engines that have been tested and obviously stood the test of time. So it's definitely worth looking into. So after reading the book, I've decided this is the original boiler design. There's only, sorry, upside down. Got 3 ports here. This port here and this port here will be the water gauge. I think that's steam outlet, and then these two are water pickups from the tender. The water tank will be in the tender. I've decided I'm going to put 4 through pipes here. So I've got some boiler gauge pipe, which is this is a boiler grade I bought from, I think, Mac Tools, Mac Engineering. So this is, can't recall the thickness, I think. Coming out 1.7. I think it's 16 gauge. What does it say here? Oh yeah, I think it's 1.6, which is the same as the thickness of the tube. And this is all rated in the drawings that I got off George that he's used and tested. He's tested up to 150 psi. He's just soldered. The only difference I'm having here, obviously, I'm going to TIG weld the ends on. And everything else is going to be silver soldered in. The blocks, the through pipes, I'm going to silver solder them. So if anything, it should technically be a bit stronger because it's going to have, these will act as, also help to act as stays. I am tempted to put some in as well, just copper solid bar all the way through. I'm not 100% decided if I'm going to do that yet. But either way, I'm going to film this now. I'm going to mark up the drawings of how I'm going to put the pipes through. Get them prepped, drilled. Like in the book, obviously it says you want 6th hour clearance where you drill for the pipes, for the solder to go in. Obviously you don't want to ream it, have it a perfect fit, because then there's nowhere for the solder to take up to bind it. So little things like that are really useful. So yeah, get it marked out now and film some of it so you can see. As you can see here, this is just a piece of scrap piece of the copper. I've not cleaned them or anything, not cleaned them off, just I've been doing the prep on the boiler. And I'm just going to get this in the vise now and give it a bit of a destruction test. So the welds aren't the best. It's 160 amp TIG, that's so it's maxed out. That's using this electrical cable. So it's like a real pure copper. But the weld I'm going to be doing that will be a fillet weld, it'll be like a T-fillet almost. External on the tube. So we imagine now, well, you can see it here. The welds are going to be like this. Bit of a bridge gap here. So I'll keep cleaning these until I get them as close fit as I can. Obviously have it above it, and have like a nice area to fill with a weld to get decent penetration there. All the way around. Obviously going to hydraulic test it myself. I just want to see what this is like now, this copper, how it reacts, because obviously copper is the opposite to steel. You heat it up and quench it, it softens it, it anneals it. So you see the penetration there. This has been obviously better spaced out, a couple of mil to weld it. You can see obviously where I started here, it was a bit of a messy. There's dirt obviously in the copper. Could have buffed it up and everything, but it's getting a bit late now. As I've gone along, it's obviously got hotter and hotter, conducted the heat and spread the weld. But just for the sake of it anyway, I'll put it in the vise and knock it about, see what happens. So there we go. Just maybe get right on the weld, do it that way because grab a dead blow. That's pretty interesting to be fair. So obviously it started to tear the start of the weld, but it obviously wasn't hot enough. But it's just folded over. I mean, that's not even fully penetrated, and you can see that really well. That's not even a really good penetration on the weld. It was just completely folded over. Obviously it's annealed, it'd be softer. I reckon with a decent gap and the fillet, the nice weld in there, just a nice bead of penetration like what you have here. It's not picking up very well. You can see that obviously penetrating through the copper. With the gap, that would be perfectly adequate for what I need. Right, I'll straighten this out and is it worth... It's a bit late to be making noise really. He says why he's whacking this with a piece of bloody There you are. See, it's broke the weld there. Still bloody. God, that's still pretty tough stuff. Right. Let's try it again. What I might do is replicate what weld I'm going to be doing on the boiler, so obviously like a T-fillet. Well, corner weld, just straighten that out. Leave a bit of a gap for it to penetrate. Might do a few runs as well. Let it heat up and work away along. Right, here's a piece of obviously welded up now, the TIG welded. Similar weld that's going to be on the corner weld like. Just going to hit it with a Scotch-Brite pad and then have a look at the weld, obviously. Just clean it up. Top everything switched on. Right, so bearing in mind, I didn't clean the copper obviously before welding it. It'd be a fresh carbide, tungsten carbide insert. And obviously, I'd clean all the copper wire, clean the copper that I'm obviously welding, Brillo pad it up, get it nice and everything pristine, thin as it, wash it. This is obviously the result of welding. Picking it up, let's try moving you. It's not really great, is it? Why is that awful? Is that better? There we are. So this here, obviously, I started the weld at this back end, around the weld, and you can see obviously as it was conducting more and more heat, absorbing more heat, it was melting away a lot quicker. Very similar to aluminium, how TIG welding aluminium. I've not got, again, not a massive experience with TIG welding aluminium, but this is all the experimental sort of stage. We have got obviously penetration through. What I did here is I started there, it was nice, welding, and then I tried to weld from the corner, but obviously there was so much heat in the piece it's just melted away. So that's what this big massive mess is here. And obviously big divot here. It's the same as that, where there's too much heat going into it. But there are a few pinholes in it. Now that could be down to just inclusions of the weld, this dirt, because obviously it's not clean. But yeah, I'll take this to my mate and have a look, see what he thinks, and then I'll do another tester knocking it about. End of the day, if it doesn't survive the fucking, oh pardon me, if it doesn't survive the hydraulic test or it leaks, then to drill it out, re-weld it, fix it, and see what the issue is. It's almost like it's the cold lap, like it hasn't fused perfectly there. I don't know if it's that or it's just dirt from the Scotch-Brite. Either way, it does weld. The ampage is plenty. Just see there. It focusing. No. It's awful, isn't it? Sorry guys. Just trying to get it to something like. It's not taking it very well. The light's pretty awful. But yeah, I mean, like, it's not terrible. Obviously I'll get a bit more copper, plenty of practice before I commit to doing the actual boiler tube. I'll have to see what the strength is, TIG welded copper, in relation to silver solder. Because if I did decide to make the ends the traditional way, where you obviously make the steel swage and knock it around it to slide in and silver solder it in, I'd have to re-drill these and everything. It's not the end of the world, but it'd be cool if I can take it up. So yeah, we'll see.